Okay, we have a probability question here. 4 random people. What's the probability that 2 of them are born in the same month? Okay, so anytime we're doing the probability, we're going to make a fraction basically. And in the denominator, we're going to have the total outcomes. In the numerator, we're going to have the desired outcomes. Okay. So let's think first about the denominator. Okay, the first person, there are 12 months in which he could be born. Second person, 12 months in which she could be born. Third person, 12 months. Fourth person, 12 months. Okay. That's the total possible outcomes for 4 people. Now let's think about the desired outcomes, which is exactly 2 are born in the same month. So I want to think about, first of all, the 2 that are in the same month. So from the 4, I will choose 2. Those 2 are going to be in the same month. Now this 4 choose 2 basically is the different combinations that you could get. Let's just look at that on the side. I think that would be good. Let's say these are my people. You could have A and B in the same month, A and C, A and D. Notice we don't care about the order here. Like A and B in the same month, same as saying B and A are in the same month. Okay, and we have let's B and C, B and D, finally D and C, and this total is 6, and 4 choose 6 is equal to 6, so that's good news. Okay, now let's take those 2 people that are in the same month and say what are the possible months that they can be born in? Well, 12. Any month, right? Now the next person, there's only 11 months remaining because that third person can't be in the same month that the other 2 are in. Okay, now likewise, there's two months now taken, so there's 10 left. And this is the final answer, basically. Your calculator should, you should have these combination and permutation functions, and it's good to get to know how to use your calculator, how these things work. This, you can put that in your calculator. That's the thing to match. And then try to use these permutation combination functions. Okay. Now, what about, we can extend this, right? What about if n is 5? It's not much different. You got to do 5 choose 2. That's the different ways of arranging the 2 in the same month. There are 12 months in which they could be born. Then 11, 10, and 9, 12 power 5. Okay, now can we generalize just for n? It's going to follow the same pattern, basically. So from the n random people, we're going to choose 2. There are 12 ways, and then 11. And so I'm going to write this as the permutation function. So basically 12. This is different permutations of n minus 1, because there are 2 in that 1 month. And then the denominator is just like that. Let me make that a little more clear. Okay. I hope that was useful. And yeah, that's all. Thanks.